What's up everyone, it's Bryce from LangChain, and I'm super excited to show off our new native support for generative UI in LangGraph. This is essentially an API we've added which allows you to directly register UI components with your LangGraph server, and then inside of nodes, yield these components or push them to state, and then on the client right here, you can access those components which have been pushed to the state by your agent and render them directly to the user. So we see I sent this query, show me places to stay in New York for 8 people. That called a travel agent, which extracted some details from my query, like the location, New York, the number of guests, 8. It then called the list accommodations tool, and with calling this tool, it triggered the UI.push method, which is going to push this component to state, where it was then rendered for us right here. We can see this accommodations list component is fully interactable. I can click on them, I can go out, I can refresh the page, and they will persist all with the same data and images, and that's because they work like any other React component. I defined this the same way I would define it with any other React component. I used the same reusable components I used in the rest of this app, right? I use the shadcn library. This is their carousel component. We recognize the buttons. So you just define this like any other React component, but the only difference is you are registering it with your LangGraph config and then yielding it on the server. Another cool thing about these components is I can click on them, right? And we see this book button. If I click on this, it's going to send an API request to the LangGraph server because we give it a hook which allows it to talk to the same server. And it's going to send a new tool response message, which is going to be the booked accommodation tool response, a human message, and it's going to force the graph to respond with some text. Once again, if I refresh the page, it's going to persist with this new state because of the tool message that was added and not the original list accommodation state. Now, before we jump into the code, let's take a quick look at a high-level diagram to see how this works. So essentially, we have our list of components, right? Component 1, component 2, and so on, and then our graphs. We're already familiar with graphs and registering them in our langgraph.json file, and we just have to add a new component registry in our langgraph.json file to register all the different components. This component registry will essentially be a map, right, where you have keys and values. The keys are going to be names of the components. The values are going to be the components themselves. And then inside of your LangGraph node, you can use this UI.push method, which you can import from the LangGraph library, passing in the name of the component, right? Component 1, the props, and then you just need to return the UI items to state. You need to add a new state variable to your graph. And the nice thing about this is it has full type safety. So if I pass in the name component 1, it's going to require me to pass in whatever props I defined via this props field. And that way I don't need to worry about defining a random component name, or let's say I misspell the component name, it'll yell at me because it knows exactly what components are registered. So you get full TypeScript safety with pushing your UI components. You can also remove them later on or right after this. You can stream them back and much more. Then once I push this and add it to my state, inside my client, I simply use the uStream hook and the load external component JSX components. I then iterate over all of the messages in my stream, since I tie each component that I render to a message, right? We have this UI component is tied to the list accommodations tool call message. So I iterate over the messages. I then iterate over the UI items in my state, right? The same value here. And then I just return the load external component. This is just a JSX component. I pass it in the IDs of the messages. And what this does is it goes and makes a request to the LangGraph server, and it says, okay, I need this UI or React component. Here's the ID. The LangGraph server can say, okay, I have that in my registry. It's then going to respond with the JavaScript file and the CSS so that it can be rendered in your browser inside of a shadow DOM, so it doesn't affect the other styling, but still has full support for styling and everything else you can do with React. So to start, you're going to want to clone the LangGraph.js GenUI examples repository. I'll of course have a link to this in the description. So we're going to copy the git URL and then navigate to my terminal to clone that and jump into the code and see how this actually works under the hood. So I'm at my terminal. I'm going to run git clone and then the git URL. I hit enter. We can see it clones, and then I can navigate into that directory. Once I'm in here, I'm going to run pnpm install. This project uses pnpm, and I want to install my deps. And while this is installing, I can open it up in my IDE, and we can look at the different environment variables that are required and set those. So if we open up the .im.example file, we can see that the only keys that are required are OpenAI and Google. We use Google as a routing node and the supervisor agent in this example, just because Gemini 2.0 Flash is very quick, and then OpenAI just for general purpose tool calling. You can also set your Langsmith API keys if you want for best-in-class tracing observability. However, this is optional. And then this repo has a few different agents in it. So you can see if we open up the agent directory, we have a chat, email, code, pizza order, and so on. Just different agents to demonstrate the different types of generative UI, and then also just tool calling and chat interactions with the agent chat UI, which we saw in the beginning of the video. So if you want to be able to use all those agents, you'll need an Anthropic API key and a financial datasets API key. In the README, all of these API keys and links to get them are outlined. So of course you can go and set those later if you don't want to right now. So I'm going to copy this file, paste it, and then rename it to be just .env. And then I'm going to set my OpenAI and Google API key. Great, so I've set my environment variables, and the first directory we're going to look in is the agent UIs. You can see we have an agents and agent UIs directory. This contains the LangGraph agents, and this contains the UI components which my agents will yield. So we're going to be looking at the trip planner agent and UI components in this video. So we're going to open up the trip planner directory, and inside here you can see we have two subdirectories: accommodations list, which is the UI component we just saw, listing the different accommodations or hotels, places to stay. And then restaurants list, which is another UI component that can be yielded if you ask it to recommend you restaurants. Let's open up the accommodations list file or folder, and you can see we have an index.css and an index.tsx file. Inside the index.css, if we want to use Tailwind or add any custom styles, we can define them here. However, this is not required if you don't want to do any custom CSS like this. And then inside my index.tsx, you can see we're importing my CSS file, and then I have a lot of React. This is just general React code. If you've ever written React code, you should recognize this. There's nothing different. You're literally just writing React components, and then you're able to yield them inside of your LangGraph nodes. So as you can see, I have a bunch of different components. I'm going to collapse them all, and we're going to scroll down to the accommodations list component. This is the main component, which is yielded every time you called originally. And we'll start from the top. So you can see I defined some props. This is because inside my LangGraph nodes, I can pass it props because these components are dynamic. So I require a tool call ID, trip details, and accommodations. The trip details are the trip details that we got from the extract tool call that we saw in the beginning of the video, and accommodations are just a static list of different places to stay, which I've predefined because we're not actually calling a travel API. Now, the very first line, we define this thread variable, which is the result of the uStream context hook. If we scroll up, we can see that I'm importing this from the LangGraph SDK React UI package. And this is a special context hook that we provide to all the different custom UI components if you yield them. So you can only access this inside of a UI component which is being yielded by a graph. If you're not inside of one of these custom generative UI components, you would just use the plain uStream hook. But inside of these components, we want to be able to give them access to all of the same API requests and state values that we do in the uStream hook. So we have this custom uStream context hook, which is provided to it. You can see we passed in generics for the state of our graph, which is a messages key and then a UI key with a list of UI messages. Below that, we define two state variables, one for the selected accommodation. Whenever you select an accommodation to show more details, it gets set right here. And then whether or not an accommodation is booked, so true or false. After that, we run this use effect on the very first load every time. And essentially what it does is it goes to check to see if you've already taken the action inside this component. So this action is booking the accommodation. So we say if accommodation booked is true or the type of window is undefined, so we haven't loaded around the client yet, then return. Right? So if accommodation booked is true, don't load this. If this is false, it likely means that it's the first page load, and we're going to call this getToolResponse function, passing in the tool call ID and the result of the uStream context. This is just a util function which takes in the tool call ID, the thread, and then iterates over all of the messages in the thread, and it attempts to find a tool call response. So message type equals tool. This is a tool response message, which has the same tool call ID that I passed in. We do this because in order to trigger this accommodations list component inside my LangGraph graph, I call a tool. So we have an AI message with a tool call. That is the list accommodations tool that we saw in the chat agent UI. And then once that's called, we render this UI component. Now, if a user is going to book an accommodation, the way we set that in our graph state is by sending in a tool response saying booked accommodation. And we do that because on new page loads, we want to be able to check and see if the user has booked an accommodation. So if we pass in that tool response with the corresponding tool ID, and that's then in the state, we know that the user has already taken the booked action, and we should show that this is booked. If there is no tool response with that tool call ID, we know that no action has been taken, and we don't need to do anything. But if this is true, we then set accommodation booked to true, and then we parse the JSON of the content field. When we look inside the handle book accommodation function, you'll see that we're actually setting these two details inside of the tool message when we submit it. So we extract that content and then set the selected accommodation field just so the booked accommodation component is able to render with the proper details that the user booked. Now let's look at the handle book accommodation function. If we expand this, we can see it takes in an accommodation and then creates this order details object with accommodation and trip details. You can see these are the same that we extracted from the tool result context or content. And that's because when we submit a new run in our thread, we pass in a list of messages, and this contains the tool call, right? This is the tool call that our getToolResponse function was able to extract with the tool call ID, this special do not render ID prefix, which basically tells the agent chat UI, don't render this tool response in the UI. The user does not need to see this. And then the stringified order details. So you see right here with the order details, we stringify to put into content, and then we're able to parse that on every page load. We also add this human message just for some added user experience so that the user can see that they booked this accommodation name for this many guests. One other thing, we're not just passing this new request in via the first argument, which would be just updating the state and triggering a new run. Because our agent, which calls the travel planning agent, is a supervisor, the way it works is it first calls a router node that then determines based on your chat context which agent it should route to. If it does decide that it wants to go to the trip planner, it'll route there. However, in this case, we know that if you book an accommodation, we don't want to go to the router. We know exactly where we want to go. It should be the general input response because this typically can trip up the router because it sees that there's a book accommodation tool call and it thinks it needs to call the trip planning agent. So we use the command API to just update the state with this new tool message, human message, and then tell it go directly to the general input node, which is the last node in the supervisor agent, which just sends a plain text response. And if we go back to the chat interface, we can see that is the result of this. So we booked accommodations to human message, and then we had the command API call the general input node directly, and that sends in this text message. So we then set accommodation booked to true because the user just booked the accommodation. And then we have a check right here, which we don't need to worry about. Now, we have these right here for on every page load. So on the page load, if accommodation booked is true and selected accommodation is true, we return this booked accommodation component, which is this component right here, right? So we have our use effect. It runs. If it finds a booked accommodation, it sets these state variables, and then we're able to return that UI component. If just accommodation booked is true, like if we weren't able to parse a JSON, we still want to say successfully booked accommodation. Next, if just selected accommodation is true, we want to return the selected accommodation function or React component. And this happens when a user selects an accommodation inside of that carousel list. We want to then render just the selected accommodation view. And then finally, we have the main carousel component, which renders all of the different accommodations via this accommodation card. So as you can see, it works just like any normal React component. We can call APIs. We have access to that UStream context hook. We have the use effect hook, and we're just rendering React components like you would with any other component. So that is how you would implement a generative UI component. Now that we've seen that, we can go into the index.tsx file inside of our agent UIs, and you can see here we're defining a component map. We need to do this because we need to register all of the components we have defined for our agent inside this component map function. And then if we open up our LangGraph.json, you can see we have this new UI object where we pass in a key agent, and this is which agent in our graphs should have access to these UI components. So we see the main supervisor agent should have access to all of the UI components inside this component map. And that's how we register our UI components with our graph, and it's how we're able to map back to them inside of the LangGraph nodes, and then also on the front end in our web app to actually show them to the user. So that is how you will manage and register all of your UI components. Now let's jump into the agent code and see exactly how we're yielding these UI components inside of our nodes based on tool calls or any other logic. Okay, so I'm inside of the tools.ts file, which is just a simple call tools node. If we quickly go and look at the trip planner agent, we can see there's a few nodes before this to make sure we have the proper trip details, and then eventually it'll call the call tools node. Inside of here, very simple. we first define this typed UI function, which we import from the LangGraph SDK React UI server, passing in a generic of the component map so that this UI value knows exactly which components have access to it. And it needs this so that it knows which names of the components, and then also the types for the props. So we pass that in, and then also the config, and that's how it's able to map it back with our LangGraph server. So now we have our UI value here, and this is how we're going to be creating, removing, and editing UI components. And then we just have a super simple LLM call to chat OpenAI. We bind a list of tools. You can see it's list accommodations and list restaurants. We saw the list accommodations tool call right here. And they are empty objects just because we want the LLM to say, okay, if the user wants to list or see accommodations or see restaurants, call this tool or call this tool. And then after we call the response, we find the tool call using another util, which just returns the name, args, and tool call ID based on the name of a tool call from the response. So we say if list accommodations tool call is true, then we're going to use this UI value, which we got from the typed UI function, and we're going to push a new component. There's a few different methods you can call on this. So if we look at the return type, we can see that it gives us access to push, delete, and items. So push, of course, is how you create a new component. So whenever we have this tool call, we want to render this component on the client. So we push a new component, passing in the name. And if we go back to our component map file, we can see that the accommodations list key maps to our accommodations list component we just looked at. So we're passing in a name of accommodations list so it knows which component to access, and then a series of props. This is the tool call ID, and then the trip details and accommodations. So we pass in that name and props, and then also a corresponding AI message. And this is how we'll know where in the list of messages on the client to render this UI component, so that we don't, render this at the top or way down below. How it's able to know even after, my graph is not running. But that's how it's able to know after each refresh where in the state to show this UI component. So once again, we have our name, which is the name of the component from our component map, pass in any props, and then the corresponding AI message that we just called. We do the same for restaurants, and then we return our AI message and UI.items. We return this into our state so that our LangGraph state knows which items were set in the UI. And it saves that in a checkpointer, once again, so that after every page refresh, or if we want to, say, go back in time to some specific checkpoint in our thread state, we can do that. You can also call UI.delete, passing in let's look at the return type. So UI.delete, passing in an ID, which returns a remove ID message. If we were to do that, we would, of course, need to return UI.items as well, so it has that remove message. And that's how our LangGraph state knows which UI components to remove. And you would get this ID from the UI message. We can see that push returns a UI message, and inside the UI message there is an ID field. So you just pass that ID to delete, and that's how you can remove components from the thread state, and then once again from your UI. So as you can see, it's fairly straightforward and simple. We just have this UI field in our state, right? UI, which is just a list of UI message or you remove UI messages. We call push or delete to add those to our state and then to have them rendered on our client. And then we return UI.items at the end of our node. So that is how you define and build UI components in LangGraph and then call them and yield them in your node. Let's quickly look inside of the chat agent UI code base to see exactly how we're able to find these components and then render them in the UI like we saw in the demo before. Before we do that, we're going to want to go to our terminal, and we're going to want to start the server. So we just saw how this all worked. We're going to run pnpm agent, which is going to start the LangGraph server running at HTTP localhost 2024. Now if I go back here, I can refresh, or I might need to create a new message and go back to it. Great, so we can see this is a previous thread, but we have it running at port 2024. We're able to access these, it can refresh and all of that. Now let's actually jump into the agent chat UI code, which you can access yourself via two ways. One is the npx create agent chat app command, which will just clone all the code for this web app onto your local machine. Or of course, you can just clone the repository directly. I already have it on my machine, so I'm going to open it up and we'll look at exactly how this is working. So I'm going to open it up in my IDE. And then we're going to want to navigate to the ai.tsx file. Inside here is the component we use to render all of the AI messages, right? So all of the messages on the left. And if we look, we can see that there's some logic for rendering tool calls. And then we have this custom component, JSX component right here. We pass in a message, which is the current message in the list of messages we're trying to iterate over. Or sorry, which was passed to this assistant message. And then the thread. The thread is once again the result of uStream. I've wrapped uStream inside of a context hook, but we can see, where is it? Right here, I'm just using the plain uStream hook from the LangGraph SDK. This is different from the uStream context that's imported from the LangGraph SDK inside of our GenUI components. This is just the uStream hook, basically. And now, if we look inside the custom component, we can see it accepts the message and then the result of the uStream hook. We extract all of the values from the state from our current thread via the uStream hook, and then we iterate over the UI field, right? We saw, if we look inside of the state in our LangGraph graph, we have this UI field in the state. So we're iterating over all of the UI messages here, and we're filtering to only return UI messages where the message ID equals the assistant ID. And we're able to do that because we specified this AI message right here, right? And we returned both the AI message and the UI messages. And this is so we can say yield multiple components inside of a single run, where we have one component which is tied to an assistant message here. The user sends a follow-up, and then you have another assistant message with a different component. We need to do this so that we're able to render them in the proper locations. So after we get back all the custom components from that message ID, if there's nothing, we return null. But if there are components defined, then we just iterate over all of the components and then return this load external component function. We import this from LangGraph SDK React UI, and this is a JSX component which is basically going to be able to take this UI component ID and make a network request to fetch that JS and the styles and render them in a shadow DOM so they don't affect any of your other styles inside the browser. And we can see that if I open up my network tab, right, and I'm going to filter for all and refresh, or let me make it a little easier. We'll go to just JS. If we look in here, we can see there's an entry_point.js request. This contains all of the JavaScript. It's of course going to be bundled, but this is the JS file which renders this component right here. And if I look again and I filter by just CSS, we can see there's a entry_point.css, which is the corresponding CSS styles for that component I wanted to yield. And that's what this load external component JSX component is doing. It's taking in the component ID, the thread, the message, and then some metadata, and it's just making a request to the LangGraph server and saying, hey, for this component ID, give me back the JS file and the CSS so that I can then render it in the UI. So as one final wrap up, we can look at this graph. As you can see, we have our components and our graphs. We then register that in our langgraph.json, right? So component 1, component 2, component 3, component 4, and then our graph agent 1. And then inside of our LangGraph node, we push components using the name, so component 1, any props, we then return the UI items. And then inside of our client, we use the uStream hook to get back all of the values. We iterate over those UI messages and then return them inside of a load external component, JSX component, which we also imported from LangGraph SDK. So that is how you use the native support for generative UI in LangGraph, where you can register UI components with your graph and then yield them directly within nodes and load them on a React site or any other website you want to load your generative UI components on. I hope you all enjoyed this video. Of course, I'll leave links in the description to all of the different repos and sources I use, as well as the documentation for generative UI and uStream. And I hope I see some really cool generative UI apps built with LangGraph soon.